Left you people here at Mrs. Bad Crumble's grade 3 version of multiplying, yes? Yeah. Except, of course, Mrs. Bad Crumble in your textbooks back then had, there's 1 apple, there's 2 apples, there's 3 apples, and then Mrs. Bad Crumble said she took that whole group of apples and then she did and then there was 3 apples and another 3 apples, and that was 2 times 3. And that's how Mrs. Bad Crumble taught you multiplication. Yeah, it is. That's exactly how you were taught multiplication when you were a little kid. Except it might not have been apples. She might have chosen a different object. Something that you all would have recognized. For you people, your dad has 3 cell phones. Yeah. Your dad has 3 cell phones. For you people nowadays, some sort of material that is in Fortnite. I don't know because I, of course, have a life and have never played the game. So, this is grade 3 multiplication, yes? In the example from actual grade 3, there was 1 apple, 3 apples, 3 times 2, 3 and 2 are the factors. In grade 10, your factors are no longer numbers, or are they? All of you will say to me, Mr. Myers, x plus 1 isn't a number, but x plus 1 is a number, isn't it? If I tell you that x equals 3, then what do I have there? I have 4. 5 times 4 is 20, correct? And isn't 5 times 4 exactly the same as Mrs. Bad Crumble's grade 3 math? So, what I'm saying here is 5 times this. The brackets have grouped that as one thing. Everybody cool? So it's the same as 5 times 4. It's just 5 times x plus 1. But x can be anything. So I draw x plus 1, just like I drew 3 apples, and then I drew it 5 times, because it was 5 times x plus 1. Yes? Now, hopefully at some point in your elementary school career, as I've mentioned in our surface area unit, you graduated from groups of 3 apples times 6. You graduated to this situation. 1, 2, 3, 4. 4 by 5, right? And the answer to 4 by 5 lied in the middle, and it was 20. Because 4 times 5 is 20, yes? And multiplication is commutative, which is a word we almost never use anymore. But what that means is I could take this rectangle, split it into 5 this way, 1, 2, 3, 4, 5, and then split it into 4 this way. 5 times 4 is 20. Or I could have split it into 4 first, and then 5, because 4 times 5 is 20. Everybody is good to there. That's elementary school multiplication. So now we are going to take all of those elementary school models and apply them to a high school level question. And what that means is we will make a rectangle again. And as you well know, width times length gives me area. Width and length are both factors, yes? If this is 4 and this is 5, the product is 20. So we know that we have factors living on the sides, yes? And we know that this 5 is one of the factors, and this x plus 1 is the other factor. So on one side, we have 5. Now, this symbol, 5, is not 5 things, is it? Is it? It's one thing, right? 5 things is that. But we have a symbol to represent 5 things. It's this. The Romans had this. Everybody cool? Okay. So since this is a symbol, and over here we're drawing it, we are going to draw 5 little guys. Because that equals 1. And there's 5 of them. The other factor is x plus 1. X, because we don't know how long that is, and since we don't know how long it is, we have to give it a variable, because it's an unknown value. And then plus 1, we know 1 looks like that. So I get that x, because that little 1 stretches out that length. Then I get that little 1, but it stretches out to that length. And I do that 5 times. And then 1 times 1 is 1, 1, 1, 1, 1. And my answer is in the middle here. 1, 2, 3, 4, 5 x's. 1, 2, 3, 4, 5 that are positive. Everybody with me? So my answer to this, you have 5 x's and you have positive 5 little guys. Everybody with me? But math guys don't write this. We write 5x plus 5. Now what if this guy was negative? What would happen to all these guys? Positive times a negative. They'd all be negative, wouldn't they? Yep. So what we would have, we wouldn't have 5x and positive 5. What would we have? 5x and negative 5. So in actuality, what we would have would be 5x and negative 5. But math guys are lazy. They don't want to write this. It looks confusing. So what do we write instead? 5x minus 5. Subtraction doesn't exist. It is adding negative numbers and then being too lazy to write this. Is everybody good? Okay. Now that leads us to the next thing. Again, something you already know. Algebraically means we're using numbers. We are not going to use a picture. And what that means is simply this. If there was no plus 1 there, what does this mean? What does that mean in math? 5 times x. Do we know what x is? No, so we have to write 5x, right? If there was no x there, what's 5 times positive 1? Positive 5. Positive 5. 5x plus 5. Everybody cool? You all already know that, but you need to know why it works. That's why it works. Everybody cool? All right. That is what we call the distributive property. You have heard it been given a whole bunch of other names. You have had your teachers give it cute little names. You have had your teachers draw arrows and stars and leaping frogs and all these kinds of things. But what it is the distributive property. And what it says is this. A times x plus y equals a times x plus a times y. And how long does that go on? Forever. So what if I had a times x plus y plus z? What would the answer be? Ax plus ay plus az. What if I had 16 terms in here? How many would I have over here? 16. And what would be the first letter in all of them? A. And each A would be multiplying by whatever was in there. Does everybody get it? Okay. That's the distributive property. You've heard it called other things. I will not use any of those other names because I use the real words. Because when you get to university, as some of you plan to go to, your prof will not have cute little names for the math he or she is doing. He will call it, or she will call it, what the math is. And if you look at him or her like this, they will not say, "Are you okay? Do you know what I'm talking about? Is everybody cool?" They won't. This is what they will do. Turn their back on you, turn back to the board, and continue to do math, leaving you completely behind. Does everybody understand? That is why I am slightly meaner to you, maybe, than previous math teachers. Because I've got to prepare. Somebody has to prepare you for going out of here. And if everybody else is going to be soft, somebody's got to be hard. That's me. Okay? Get your mind out of the gutters. Cool? Okay. So here we are going to do a picture and we are going to do algebra. To do the picture, I must remember in my head, it is factor. Oops, I should have been doing that in black. It is factor 1, factor 2 on the outside, and product in the middle. What is the first factor here? What's the first factor you see? X. So I'm going to put factor 1 on one side. X. Agreed? Factor 2 is going to go here. What's factor 2? 2 x's. So there's 1x. There's a second x. And minus 4. Now, I taught a kid in the past. We were doing these, and he always got the right answer in practice. And then I gave him his test one day on it, and the whole class was finished the test, and he was on question like 3. I said, how much more time everyone need? And this kid says, I'm on question 3, Mr. Myers. I said, what? How can you be on question 3? You know exactly what you're doing. I went over and I looked. Dude had a ruler out. Dude was measuring every x, so they were exactly the same. 1 centimeter thick, 2 centimeters wide. Every single one. These were 1 by 1. Drew every single one with a ruler. And if it wasn't a good 90 degree, do you know what he did? Erased it and started again.
Oh my goodness.
And I was like, dude, you know what you're doing. I'll just take that. And I gave him the A. Because, of course, really, ruler. Anyway, another story for another day. Where's the answer live? In the middle. So I started with this x, correct? But that x did what? It stretched. It ruined it. Don't, oh, you're such a piece of crap. Ruined my thing. It was going to be awesome. Oh, it did it again. Ooh. Hulk smash. Okay, here we go. Pretend like this last 30 seconds didn't happen. So you had this x. And it stretched that far. Now what do you have? No. You have x and x, which makes x squared. What do you have here? Another x squared. This time, it doesn't stretch any further right, but it is negative. Because negative always wins, even in the real world. So what is my answer to this question? All you got to do is count. How many x squareds are there? 2 x squareds. How many x's are there? 4, but they are not. They are negative. That's the answer. Yeah? Yes, 4x. Thank you. And then over here, we do the distributive property. Right? X times the first one. We just did a unit on exponents that you're being tested on tomorrow. What is the coefficient in front of x that we don't write? 1. Coefficients go together. What's 1 times 2? 2. What's x times x? X squared, because that's x to the 1 and x to the 1, and we add the exponents. What's x times 4? 4x, and it needs to be negative. Now, obviously, one of these is easier. Which one? The pink one, the distributive property, is significantly less work. But I want you to make sure that you know what is actually happening. And these are going to help me teach you another math concept in a couple of days, which is why I'm spending so much time with something that for most of you, you don't need to see. Some kids find algebra tiles are very helpful in understanding why the distributive property works. A few kids every year are like, oh man, thanks for showing me algebra tiles. But it's only a few. If you're one of those, you're welcome. If you hate them, No big deal. They're just a tool. Okay? Okay. You guys do the next one by yourself. Go. Get out your rulers. If your X bars aren't perfect, I'm docking you marks. True story. No. You got dimples. Everybody good? Okay. Yeah? 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 Easy peasy lemon squeezy, yeah? Okay. Turn the page over. Now notice, we're in a new situation, aren't we? Because now it's binomial, right? Now again, I'm not going to make you actually play with algebra tiles, but I do want you to draw it out. It looks different. Do the rules change? Of course not. Is this a factor? Yes, because it's a single thing multiplying by another thing, yes? So this is factor 1, this is factor 2. Where do the factors live? On the outside. Well, how do I draw x plus 3? I draw x, then I draw 3 little ones, yeah? It does. Wait a sec, trust me. This is going to be x plus 2, correct? Now, why, get out of my head, guys, did I switch factor 1 and factor 2? Because multiplication is commutative. 5 times 2 is the same as 2 times 5. Which all of you think is something everybody knows, right? Yeah. Like, of course 5 times 2 is 2 times 5. What kind of a moron doesn't know that? That's so easy. It's like the second thing that you ever learn. And truly, you don't have to care about that property of multiplication until like 4th year math. But when you get to 4th year math, this very simple piece of knowledge, 5 times 2 equals 2 times 5, becomes absolutely essential to doing higher level math. Because you move stuff around all the time. Everybody cool? So make sure you are aware of that. That's why I mixed it up. So now, do the rules change? What's going to happen to this bar here? It's going to stretch out to fill up that, right? What's going to happen to this here? It's not going to stretch, not going to stretch, not going to stretch. Here, what's going to happen to that little guy? It's going to stretch. What's going to happen to that little guy? It's going to stretch. And what am I left with here? Little guy and little guy. Little guy, little guy, little guy, little guy. Oh, wait, I don't want to be gender specific. Little person, little person, little person. Okay? Everybody good? What? How? Okay. No problem. Let's do this. I just drew Washington. Okay. Pretend, Karen, that I'm only asking you to do x times x, right? Okay. So you can see on the left side of this drawing, I have this bar, correct? Right there, yeah? But I have to fill up this amount of space, yes? So I have to make this bar stretch until it fills up this space, right? You with me? Okay. Okay, I'm going to try to do this another way. That is 4 long. Okay? That is 4 long. How do I fill out this square? How? What will I have to put here? A what? A line. How far will it have to go to the right? 4. Excellent. How far up will it have to go? 4. Excellent. Well, in this case, how long is this box? No. X. Right? So how long is this side? X. Now, if I turn that sideways, how long is this side? X. So how big is the thing in the middle? X squared. So I had x there and x there, didn't I? They're both the same. So I got to finish that square, and everything is x. So it's x squared. Cool? Now here, I still have the x, but I've only gone across 1, haven't I? So that is why that is 1 times x. That is 1x. What's this one going to be? X, 1 wide, 1x. What's this one going to be? 1x. Cool? Now here I'm starting with 1, but how wide is it? So I got to stretch out that way. And what's this one going to be? 1, and it stretches x wide, yeah? And then here I got 1, and how far does it stretch wide? 1. Whoop, whoop. Here. Whoop, whoop, whoop. Here. Whoop, whoop, whoop. Oh, wait a second, dummy head. I don't need to do that. They saved this over here for just such an emergency. Fortunately, I keep my feathers numbered for just such an emergency. You guys know who I mean, right? Foghorn Leghorn, the big rooster on cartoons? Yeah, that guy. But I can't talk like that guy because that guy's pretty racially insensitive. Well, he totally is. Everybody, are you good now, Karen? Okay, so everyone's cool with this as a picture? Now, okay, if you can draw it as a picture, because again, the rules don't change, let's do this algebraically. We started with x plus 2 and x plus 3, right? Even though the original facts were written backwards, I can switch the order. Why? Because it doesn't matter, because multiplication is commutative. 2 times 5 is 5 times 2, yeah? Okay, now, if there was no 2 there, what would you do with that x? You would distribute it, right? And what is x times x? X squared. And then what is x times positive 3? Positive 3x. Does everyone agree? Okay. Now pretend there's no x there, but there is a plus 2. What would you do with the 2? Distribute it. What's 2 times x? Now I already have some x's, don't I? What should we do with everything that's the same? We should collect our like terms, right? Because it's not necessarily going to be add, is it? So I am going to do something differently than what your grade 9 teacher did here. I bet your grade 9 teacher wrote 2x right there. If you even saw this in grade 9. I don't like doing that because eventually the polynomials are going to get gigantic. And you're going to have a whole line of things that is huge. And if you do that thing your grade 9 teacher said where you draw a shape around everything that's the same, eventually you're going to have 47 shapes. You're going to run out of shapes. You're going to be like, oh man, I already used an octagon. I guess I better use a dodecahedron this time. Understand? So I don't like doing that. So here is what I do. That was pretty funny, right? I know, thanks. I don't like doing that. So here's what I do. When I get to this 2x, I see I have an x. I write it right below. I've got a new term, so I'm going to start a new line. And then what's 2 times 3? 6. And I follow that line through. Now notice, x squared, there's nothing there. What is x squared plus nothing? X squared. What is 3 positive 3 plus 2? 5x. What is 0 plus 6? 6. And what do you see? X squared. X squared. 1, 2, 3, 4, 5 x's. 5 x's. 1, 2, 3, 4, 5, 6. 6. Everybody cool? Now, how many people in grade 9 did binomial? A couple? Okay. That means your teacher showed you this little trick, which is first, FOIL. Outside, inside, and last. Guess what? I don't like that. Because it only works when there's 4 things. Right? It only works if you have x plus 2 and x plus 3. Because you can only draw 4 arrows there. Correct? What if I gave you this? X cubed plus 3x squared minus 4x plus 7 times x cubed plus 3x7 minus 2x plus 4. Does FOIL work? No. So I don't like it. But since every one of you has been shown it, I'm going to take a moment to discuss it. 1 moment and 1 moment only. And then I am not going to use that term again. I'm going to call it what it is, the distributive property. The first, you take the first term, x, and you multiply it by the first term, x. Black line, black letters, black line. Second, you take the outside 2, x times 3. Then you take the inside 2, 2 times x. Then you take the last 2. Everybody loves these type of mnemonic devices. They're the best. It helps everybody remember how to do everything. I personally would rather learn how to do it than learn an acronym. But that's just me. Everybody cool? Just like I know that the planets of our solar system are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, not Uranus, Uranus, Neptune, and Pluto. Pluto is argued. Sometimes it's a planet, sometimes it's not. Sometimes we kick it out of the club, sometimes we bring it back in. I grew up with Pluto being the last planet, so I leave it as the last planet, no matter what anyone says. Okay? There's a fun little way to remember all those, but guess what? I don't remember it. I remember Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. I can't remember what the fun little way to name it is. No. There is. There's a little acronym. It's like My Valentine Eats Marshmallow. It's something like that. To remember the first letters. That's what I say. But apparently not. So, everybody cool? Now what is really happening here is what I showed you right here, isn't it? We got rid of the 2 and we distributed the x all the way through. Then we got rid of the x and we distributed the 2 all the way through. Every time I started with a new factor, I made a new line and I kept the groups together. Now, if your method of drawing triangles and squares and circles and octagons and pentagons and all that works for you, do you have to change it? No, of course not. But I'm warning you now, when the polynomials get big and it's written on a piece of paper, typed, it gets really hard to fit that many shapes in it. Okay? But this, you can do all the time. But it is totally up to you. Yeah? Excellent. Let us move along then, cabbages. Do that one, algebraic only. Don't draw it. And then I'm going to show you something. I'm going to break my own rule because I like to keep you guessing. I'm going to give you a shortcut. I know, right? Normally I spend my whole time telling you forget them. But I'm going to break. I got to keep you guessing. It's no fun if I'm always the same. I am. But like all shortcuts, it's only going to work some of the time. Oh, I chose 2 new colors today, everyone. I added mint green and aqua. I added aqua because Sophie Friesen had aqua nail polish. She was sitting right there, and I thought it was a cool color. So, yeah. Do you want to add a color, Derek?
I mean, sure.
Okay. What would you like? A new pink? Which pink? That pink? They call that pink purple. That one? On the left. That one? That one.
Yeah.
That's just plain old pink.
Oh, okay, the one up. No, that's just plain old pink.
That's weird. Pink, pink. Red. Rose.
Oh, yeah.
I think I have rose already. No, I think that is a rose highlighter. Let's add it. That's cool. Okay. And there it is. Rose. Yeah, that's pink pen. And that's rose pen. It is definitely different. Excellent. Okay. Let's go rose. No. That's okay. Get used to it. Disappointment happens. Right? I had bigger plans. And yet. Okay. So what do I do with the x? It distributes. What's x times x? X squared. Ooh. And then what's x times 4? 4x. Now, I move to a new number, so I'm going to move to a new line. I am. You don't have to. What do I do with negative 1 and x? It becomes negative 1x. And what is negative 1 times positive 4? Negative 4. And then I just add it up. X squared plus 0 is x squared. 4 minus 1 is 3x. And 0 minus 4 is negative 4. Yeah? Easy peasy lemon squeezy, yeah? Okay, now work with me here. Observe. Do you notice a connection between 4, negative 1, and 3? What is it? Subtraction, isn't it? 4 minus 1 is negative 3, correct? Now look back in the original question. What do you see? 4 and negative 1, right? Do you see a possible shortcut? X squared, x times x. Now, what is this middle term going to be? It is going to be, if I had x minus a, x plus a, and x plus b, what did I do with those two to get the middle term? I just did the math, yes? This term right here was a plus b times x, correct? Well, 4 plus negative 1 is x squared plus 3x. Now, is there a relationship between not between son of a, is there a relationship that you can see between 4, 1, and negative 4? Multiplication. So this third term would be what? Plus a times b. So it would be negative 4. Does everyone see the little shortcut? No? I'm hurtful. Let's go back to this one. What was our answer here? It was x squared plus 5x plus 6, correct? Okay, what's 3 plus 2? 5. What's 3 times 2? 6. Everybody see it? I'll give you another one. X plus 4 times x plus 3. If I distribute this, it's x squared plus 4x plus 3x plus 12, correct? Which would be x squared plus 7x plus 12, correct? What's 3 plus 4? 7. What's 3 times 4? 12. Does everybody see the shortcut now? Now, is it useful? Yes. Only when it's a single letter at the front. That's the only time this helps you. But if I give you 10 of those questions and you can do them in 5 seconds each instead of writing them out every time, does that save you time? Yes. And this little shortcut helps me teach you something in a couple of days. So just to remind you before I shut up and let you do some work on your own, what would q plus 3 times q minus 4 be? Minus 1q minus 12. What would j plus 4 and j plus 6 be? J squared
Plus 10x.
10j plus 24. Excellent. Do you all see it? It is, isn't it? Now, what is different about this one? Can I do the shortcut? No. So I actually have to distribute this one. 2j times j, 2j squared, plus 12j, plus 4j, plus 24. Now you'll notice the last one didn't change, did it? But the middle one changed. And I get 2j squared plus 16j plus 24. Is everybody good? Okay, practice this a whole bunch. And you will find that practice being on page 122, 123, and 124. Now listen to me. This is going to seem a little weird for the next couple of days. Everybody listening? Page 122 and 123 I want you to start on right now. Class is over in 26 minutes. That should be enough time to get it done very, very comfortably. All right? You must pay attention. You cannot forget anything else we've learned in grade 10 when you're doing this page. Okay? Okay. I want you to work on them today. Tomorrow you have your test on exponents and radicals. Yes? Now listen to me. Tomorrow, while you are writing your test, I am going to record the key to 122 and 123. I won't be speaking because you're writing a test. I will write out every step. Use that to check over your 3-day weekend that you have done 122 and 123 correctly. Because on Tuesday when you walk in, we are going to do 124. We are going to mark it as an assignment. Does everybody understand? So you need to be done to the end of 124 by Tuesday. But I don't want you to do this thing for marks if you're not doing it correctly, yes? So I'm going to show you the key to 122 to 123 on YouTube. So you can check that you're doing it okay. If you're even a little bit worried, right? There's no real reason to be a little bit worried, is there? I mean, it's just multiplying, right? Yeah. Okay. Everybody's good? All right, remember, test tomorrow when you walk in. Now, you guys are block D, aren't you? No, you're block A. I can't remember. My head's all over the place. Are you A or D? A. Okay, your test will be tomorrow first thing in the morning. All right? Now, listen. It's not an 80-minute test. It isn't. But you guys sometimes need a little kickstart in the morning to get your brains going. Do you want to lose 10 minutes of time tomorrow morning and do a couple of exponent type and radical questions to wake your brains up. If you want that, then I am taking your test at the end of the block, whether you're done or not. Does everybody understand that? Okay, I'll do that. That's no problem for me. All right? You'll have 70 minutes to do what really is like a 45-minute test. Everybody cool? Okay, go.